Since Ohm's law has to be satisfied for any row in our table, if we know any two of the three values in a row, we can find the third using I times R is equal to delta V. Well, now we know all the values of the resistances, so let's find the equivalent resistance perceived by the battery. If we were to take a single resistor and put one in each of these blue sections, those four resistors would be in parallel with each other. We can then find the equivalent resistance of those four resistors in parallel, and that resistor would be in series with resistor number 8. So let's find the equivalent resistance of this portion of the circuit. We're going to take resistor number 1 over 8. Resistors 2 through 4 are in series. So when we insert that into the parallel equation, we're going to go 1 over 10 plus 12 plus 12, which is 34. Similarly, resistors 5 and 6 are in series. So to find that portion of the circuit's contribution when we're in parallel, we're going to go 1 over 10 plus 8, or 18. Resistor 7 has a resistance of 6 ohms. So the equivalent resistance of this portion of the circuit is 2.66 ohms. That is, if we tore out that whole portion of the circuit and put one resistor in its place, without the battery being any the wiser, we should put in a 2.66 ohm resistor. That resistor, you can see, is in series with resistor 8, so the resistance perceived by the battery, or the equivalent resistance, is 2.66 plus 2, which is 4.66. We can then find the current going through the battery to be 2.58 amps. Well, if 2.58 amps are going through the battery, then 2.58 amps must be going through resistor number 8. And by Ohm's law, 2.58 times 2 is 5.12 volts. So that's the pressure difference across resistor 8. If we now color code wires with voltages, this is a 12 volt battery, so the lowest pressure will be 0 volts, and this entire left portion of the circuit will have a color of 12 volts, or an electric pressure of 12 volts. We can see in the lower left corner of the table that the pressure difference across resistor 8 is 5.16 volts difference from one side of resistor 8 to the other. The bottom part of resistor 8 has an electric pressure of 0 volts, so the top portion of resistor 8 must have a color, or an electric pressure, of 5.16 volts. Which means that we know the color difference across resistor 7. It's 12 volts on one side, 5.16 volts on the other. That difference is 6.84 volts. By Ohm's law, we can figure out the current going through resistor 7. If we now go up to resistor 1, we see that the same thing holds. The color of all of these wires on the left side of the circuit is 12 volts, or the electric pressure is 12 volts. All of these wires on the right side have the color, or the electric pressure, of 5.16. So again, the pressure difference across resistor 1 is 6.84 volts, just like it was for resistor 7. The current going through resistor 1 can then be found to be 0.86 amps. Okay, well, now what? Well, we're told that the current going through resistor 2 is 0.202 amps. If 0.202 amps is going through resistor 2, then 0.202 amps must also be going through resistors 3 and 4, which allows us to calculate the pressure difference across each of those resistors. Now, let's look again at the current going through resistor number 1, which is 0.86 amps. 0.86 amps, 0.86 arrow tails, 0.86 amps, 0.86. Now we have about 0.2 amps coming this way, which is going to join up with the 0.86 coming down. So if I were to put an ammeter right here where my laser pointer is, it would be about 0.86 plus 202 amps, which is about 1.06 amps. Then we have resistors 5 and 6, whatever current is going through there, plus 1.06. So right here, if I were to put an ammeter, it would read 1.06 amps plus whatever the current is going through here. Well, through resistor 7, we have 1.14 amps. So 1.14 amps plus 1.06 amps plus resistors 5 and 6, whatever current is going through there, the sum of that has to be 2.58 amps, which means the current going through resistors 5 and 6 is about 0.38 amps. Check it out again if you want. 2.58 amps are going through the battery. If 1.14 split off to go through resistor 7 and 0.38 split off to go through resistors 5 and 6 and about 0.2 split off to go through resistors 2 through 4, then there will be about 0.86 left to go through resistor 1. Check it out yourself if you want. You can then find the pressure difference or the color difference across resistors 5 and 6. The sum of those pressure differences is very nearly equal to the pressure difference across resistor 7, which is 6.84 volts. Similarly, the sum of the pressure differences across resistor 2 and 3 and 4 is also very nearly 6.84 volts. Little rounding error, but it comes out to be 6.86, close enough. Certainly, one doesn't need a chart to analyze circuit problems. Often we are asked only to solve for particular values. Even so, my students have had success using the circuit Sudoku charts, as they make it easier to identify what can be readily calculated and what else needs to be found. One nice thing, for students, about circuit Sudoku is that there doesn't have to be much work to show, unless you have a stickler for a teacher. Anyway, find some circuit problems, chart it up, and have fun.